Hey everyone, I hope you're doing well. So today we're going to start looking at our exponent rules. Sometimes you'll hear them called properties of exponents or exponent laws, but I'll just say they're the rules of how exponents work. So the first thing I'd like for you to do is draw a table, and this can take up your whole page. That's fine. So in this table, I want you to have 3 columns. I want you to make one title row, and then the rest of them, I want you to make 1, 2, 3, 4, 5. So a total of 6 rows. Probably do just a couple. 1, 2, 3, 4, 5, 6. That worked out perfect. And you'll notice my lines aren't perfect. Do the best you can. And for your titles, let's go ahead and write rule name. So we're going to give a title or a name to our rule. We're going to talk about what the rule does, like what do you do, the rule. And I'm going to give you an example. All right, so the very first rule that we're going to look at is called the product rule. And so what you'll do is these work if you have the same bases. Oh, and just really quick, let's say we have x to the 5th power. The big number, just a reminder, is called the base, or the big letter, number, whatever. And the small number, we call that the power or the exponent. So one more time, and let's say you have a number, like 5 to the 2nd power. The big number is the base, the small number is the power or the exponent. So let's say we have the product rule. You keep the base and you add the exponents. So let's say we have 5 squared times 5 to the 3rd power. You keep the base, add the exponents. 2 plus 3 is 5. Let's try another one. Let's say we had x to the 4th times x to the 3rd. You keep the base and you add the exponents. 4 plus 3 is 7. So that's the product rule. Now let's look at the quotient rule. Quotient, you'll remember, is the answer to a division problem. So again, you keep the base and you subtract the exponents. So let's say we had 5 to the 3rd power divided by 5. You keep the base, and look at this. If there's no exponent, there's a 1 there. So 3 minus 1 is 2. Let's do the same thing with letters. Let's say we had x, let's do it sideways. X to the 10th divided by x to the 4th. You keep the base, subtract the numbers. So 10 minus 4 is 6. So x to the 10th divided by x to the 4th is x to the 6th. So that is the quotient rule. So product rule, quotient rule. Now let's look at, it's called the power rule. I know it's like, aren't they all powers? Well, this is where you raise a power to the power. So what you do is, again, you keep the base and you multiply the exponents. So let's do a couple of examples. Let's say I had 5 to the 3rd to the 2nd power. I keep the base of 5 and I do 3 times 2 is 6. Let's do letters or variables. Let's say I had x to the 4th to the 5th power. So I keep the base and I multiply the exponents. 4 times 5, that's 20. So that is the power rule. You're raising a power to a power. And just to clear up, product rule, that's when we're multiplying, okay? That's when we are product means to multiply. Sorry about that. Might not should have went back to that out of order, but just that's okay. All right, so the next rule we want to look at is called the zero exponent rule. The zero exponent rule. So anything to the 0 power equals 1. So if I had 5 to the 0 power, my answer is 1. If I have x to the 0 power, my answer or my value, is 1. So that's the 0 power rule. And next, let's talk about the negative exponent rule. Negative exponent rule. So anytime that you have a negative exponent, that just means I'm going to say flip the fraction or flip its position in the fraction. Let me show you what I mean. So if I had 5 to the negative 2 power, 5 as a fraction is 5 over 1. So this becomes 1 over 5, and the negative 2 becomes a positive 2. Let's do the same thing with a letter or a variable. Or actually, let me do another example first. What if I had 1 over 5 to the negative 3 power? The 5 to the negative 3 is on the bottom of the fraction, so I flip it to the top. 5 over 1 is just 5, and the negative 3 becomes positive 3. I'm going to erase this line because I need a little bit more space. Let's do the same thing with letters. Let's say I had x to the negative 4 power. Well, x is x over 1, so I'm going to flip it to be 1 over x. It's the reciprocal is what we call that in math. And the negative 4 power becomes the positive 4 power. Let's do the same thing if the negative exponent is on the bottom of the fraction. Let's say we have 1 over x to the negative 5 power. You flip it. The x was on the bottom. Now let's move it to the top of the fraction. X over 1 is just x, and the negative 5 becomes a positive 5. So these are all of your exponent rules. You can use this graphic organizer to help you with your practice. So now let's take a look at how we actually use these rules to answer questions. So if you have a single rule, a problem with a single rule, you just kind of match up your example and do what the rule says. So for example, if I said, what is 38 to the 0 power? That's the 0 exponent rule. The rule says anything to 0 power equals 1. Or, if we had x squared times x squared, that looks like the product rule. So that just means we would keep the base, add the exponents. But what happens when we have more than one, or when they're configured a different way? So that's what I want to look at now. So for example, let's say we had 6y to the 5th times 2y to the 9th. Well, it looks like the product rule, but they now have these numbers. So here's how you would tackle this. First, multiply 6 times 2. That's all I can do there. There's nothing special about that. But with the y to the 5th times y to the 9th, I use the product rule. The product rule says keep the base, add the exponents. So that's how I would simplify or use exponent rules to simplify a problem like that. Let's look at a few more different configurations. So let's say we have in parentheses 3x to the 3rd power to the negative 2nd power. Well, I notice two different rules. I notice the power rule, your signal there is parentheses most of the time, and I notice the negative exponent rule. Well, in this situation, it's going to be easier to deal with the negative exponent first. Since everything is to the negative 2nd power, I'm going to flip that and now put everything to the positive second power. Now I'm going to use my power rule. So the 3 has an invisible exponent of 1. So this becomes 1 over 3 to the 1 times 2, because the power rule says keep the base, multiply the exponents. 1 times 2 is 2. Same thing here. Keep the base of x and multiply the exponents. 3 times 2 is 6. Now, you might have an answer choice like this, but also be prepared to fully simplify. 3 to the second power means 3 times 3, or 9, and then keep the x to the 6th. So 1 over 9x to the 6th is your fully simplified answer. Let's do a few more. Number 3, m to the 4th, n to the 6th, times m to the 3rd, n to the 2nd power. Well, again, this looks like look at your example, the product rule. They just have more than one letter or variable. So let's take it one letter at a time. So let's do our m's first. Product rule says keep the base, add the exponents. So keep the m, 4 plus 3 is 7. Now let's look at the n's. Keep the base, add the exponent, 6 plus 2 is 8. So that simplifies to m to the 7th, n to the 8th. Take a look at this one. This one I have 3 times x to the 3rd to the 2nd power. Now, this is sort of like our example in number 2, except notice the 3 is not in parentheses. So that just means I leave it alone. Now the x to the 3rd to the 2nd power is the power rule. So I keep the base, multiply the exponents. So that is 3x to the 6th simplified. Number 5. Then sometimes you'll see stuff that looks like this. 5x to the 5th power, y to the 2nd power, divided by 15, x to the 2nd power, y to the 9th power. Now, more than likely, you'll see problems like this on your EOC. No promises, but I think this is more than likely what you'll see. So here's how you tackle these. I like to say take it one column or one thing at a time. So for example, I notice I have coefficients up front. So I want to reduce them first. I have 5 and 15. Both of these are evenly divisible by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Now let's deal with our x's. Now we know the quotient rule says to subtract. Here's how I tackle it on here. I say, okay, where do I have more x's? Well, I have more x's on top. How many more do I have on top? 5 take away 2 is 3. Let's do the same thing with the y's. Where do I have more y's? On the bottom. How many more y's do I have on the bottom? Well, 9 minus 2 is 7. So you can leave it like this, or you can make that coefficient of 1 invisible to get x to the 3rd power over 3y to the 7th power. Now let's try one final example of problems you may see. So let's do 12, m to the negative 3rd power, n to the 4th power, p to the negative 3rd power, divided by 9, m to the 4th, n to the 6th, p to the negative 4th power. So again, I see several things. I see the quotient rule, I see negative exponents. So again, let's just take it one thing at a time. So first, let's reduce our coefficients. I notice that 12 and 9 both are divisible by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. And now I tackle one problem at a time, or one thing at a time. So on my m's, I have m to the negative 3rd, m to the 4th. Well, I can't have negative exponents. So that means that these move down to the bottom. So I have m to the 4th times m to the 3rd. I'm going to leave that alone for now because we'll simplify that at the end. Now let's look at our n's. I see 4 n's on top, 6 n's on bottom. Where do we have more n's? On the bottom. How many more? 6 minus 4 is 2. Now let's look at the p's. Now I notice both of the p's have negative exponents. So I have to flip them both. So I have p to the 4th, p to the 3rd. Now let's go ahead. I'm going to go ahead and simplify a little bit before I keep going. Sometimes you just have to take steps. So I've got 4p to the 4th over 3. My m's combine to give me m to the 7th, n squared, and I still have p to the 3rd on bottom. So let's do one more step here. So 4 over 3, that doesn't change. My m's all are simplified. My n's are simplified. Now let's look at our p's. Where do we have more p's? On the top. How many more? 4 minus 3 is 1. I don't have to write that invisible 1. So that is how you simplify more complex expressions using your exponent laws or your exponent rules.